Hello dear students, welcome to IMS Gate Academy. I hope you all are good guys. And in today's session, we are going to start signals and system for GATE exam. So if you are from EC Electrical Iron branch, this session is going to be very important for you. And from today, we are starting a series where we will learn the most important concepts of signals and system in most unique way, in an unmatchable form. So first of all, just do reply in chat box and confirm audio and video, everything is clear or not. Everything is clear guys, just do reply in chat box. Hello Surya, Purushottam, good morning. Good morning. Reply. Yes. So I think now voice is clear to you guys. So in today's class, we are going to start signals and system. Many students has requested, so that is why we have starting now. So students, signals and system. In chapter number 1, we are going to discuss about the continuous time signals and system. So in today's class, we will talk about the basics of signals. We will talk about the basic introductory part. Yes, Gautam, good morning, Rahul, Suresh. So the first thing that you need to maintain guys, every morning we'll meet, okay, from tomorrow I will make changes in the timing of also, we'll meet at morning 11 a.m. instead of 11:30. Today we have started at 11:30. But from tomorrow we'll meet from 11 a.m. to 12. So daily morning we are having 1 hour class. Okay. So you are not supposed to miss. Yes. Yes, Gautam. So that is why we are starting signals and system here on the IMS Gate Academy platform. You all need to attend the classes in a live manner. So first of all, student, if I talk about the signals and system, what about the syllabus of the GATE? Okay. So first we'll discuss about the syllabus part, and after that we'll enter in this part. Okay. Yes, Bharat. And we are planning to complete the complete part, but it again depends on my students. Those are attending in the live manner. Okay, this is the only motivation for the live classes. Yes, Uprendra Gautam. Yes, yes, yes. So here, if I talk about the first, dear student, first of all, if we talk about the syllabus part, then if I talk about the chapter number 1, that is nothing but continuous time, signals and system. Continuous time, signals and system. So student, this will be the flow of content, this will be the flow of chapters. In my class, I am generally trying to cover all the continuous part first. After that, we will discuss sampling part, and through sampling, we will enter in the discrete time domain. Okay. So your first chapter name is continuous time signals and system. Here we are going to discuss about the basic operation and transformations of signals like time shifting, scaling, reversal, and area calculation, as well as the energy power calculation, periodic, non-periodic signals, even odd signals. We'll discuss about the properties of system, linear, non-linear, variant, invariant, and each and everything we will discuss in an unmatchable form guys, unique form, because in my classes I am going to teach by using the conventional approach also, and as well as by using the short trick also. Those who have attended my last classes, those who have attended my previous lectures, they know very well what is the importance of classes. Yes or no? So dear student, मंजू सर आपका कितना वेट किया सर. चलिए, now wait is over. Every morning we'll meet at morning 11 a.m. So don't miss, okay? And here I have already created a playlist so that you will get the lectures also in a sequence form. Okay, guys? So if I talk about the chapter number 2, chapter number 2 will be continuous time Fourier analysis. Continuous time Fourier analysis. Continuous time Fourier analysis. That further divide in the two part, that is continuous time Fourier series and continuous time Fourier transform. Continuous time Fourier transform. So here student, the chapter number 1, as I told you, if I talk about the properties of system, I am going to give amazing short trick student. By using those short trick, whenever any questions will come from the energy power or system properties, you are able to solve within 10 to 15 seconds. Whatever I am saying right now guys, you will feel it in the upcoming classes. Okay, after attending 2 class, 3 class, 4 class, your confidence definitely will improve. Just I am saying to those who are new here, because those who already attended my classes, they know very well. चैप्टर नंबर 1 में ही 150 पेजेस कंप्लीट हो गए थे. क्वेश्चन सीरीज करा दीजिए ना भारत. Yes, Bharat, we'll try to solve many questions throughout the sessions also. Okay, in the session only we'll have a many questions. Okay, बहुत सारे examples and बहुत सारे gate questions. Every pattern of gate questions we are going to cover topic wise topic. Let us assume that if I am picking the topic energy and power signal, then from energy and power, whatever questions has been asked in the last 30 years, all the pattern, all the problems like EC21, IN15, electrical 2017, every question we are going to solve in the class itself. Okay, you are the god of signal control. Thank you so much, Surya, for your lovely words, beta. So now after that we'll start the convolution. Convolution is very important and somehow it is treated as very tough topic also. But after attending my classes, complete signals and system will become your strength. That I am giving you a, you can say that, a promise. But I am again repeating my sentence. If you want to continue the complete signals and system, you need to attend all the classes regularly with full of dedication and concentration. Okay, और you should be regular also, consistent also. ऐसा नहीं होना चाहिए कि सर 2 क्लास अटेंड किया तीसरे में नहीं है. यस और नो? आपकी एनर्जी डाउन लग रही है सर. नो नो उपेंद्र, एनर्जी बिल्कुल डाउन नहीं है, एनर्जी बिल्कुल हाई है. आप लोग जरा जोर से बोल के बताओ यार बच्चों, हाउ इज द एनर्जी? आपने मेरे यार, थैंक यू सो मच. पुरुषोत्तम डेफिनेटली बच्चों, आप लोगों की आवाज़ बिल्कुल, आप लोगों की बात बिल्कुल सुनना था. तो चलिए स्टार्ट करते हैं हमारे काफ़ी फेमस डायलॉग के साथ. काहे पड़े हो चक्कर में, कोई नहीं है टक्कर में. चलिए बच्चों थोड़ा जोश के साथ स्टार्ट करेंगे और ये जोश को आप मेंटेन रखिएगा. सो चैप्टर नंबर 1 के अंदर हम बात करने वाले हैं, एज आई ऑलरेडी टोल्ड यू, सिस्टम प्रॉपर्टीज के बाद कंटिन्यूस टाइम कन्वोल्यूशन. After that, student will discuss about the Fourier series, Fourier transform. As you all know, Fourier series is applicable only and only for the periodic types of signal, whereas the continuous time Fourier transform is applicable for the bounded types of signal. It means if the signal is unbounded, we can't determine the Fourier transform. So third chapter will come into picture, that is what? Laplace transform. That is what, guys? Laplace transform. And in the Laplace transform gives us the opportunity to define the frequency domain behavior of unbounded signals also. So Laplace transform is applicable for the bounded as well as the unbounded signal, because we are introducing one extra factor that is known as sigma. Ankit Kumar, how are you, sir? All videos are amazing. Big respect for you. I have learned a lot of you, sir. Thank you so much for your lovely word, Ankit. Thank you. Thank you. Chali, very good. Now, student, if I talk about the next, that is Laplace transform. As I already told you, Laplace transform is applicable for bounded as well as unbounded types of signal for a certain range of sigma, and that particular range of sigma for which the Laplace transform is converges or Laplace transform is finite, that particular region of sigma, the particular range of sigma will be referred as a ROC, that is region of convergence. And many questions has been framed on this topic. And again, I am repeating the same sentence, guys. All the topic will become your strength. You are just away to attend all the classes in a regular way. You should make your classroom notes effectively so that in the future, whenever you feel that you need to revise anything, your notes will be sufficient to revise. Okay, if I talk about the next, guys, after that we will discuss first of all sampling. So this is the way. This is the way of, we can say that flow. This is the way of flow where then this is going to be, we are going to discuss in the upcoming days the sequence of chapter, So first, this particular time domain is nothing but the continuous time domain, and after completion of continuous time domain and its application, after that we will discuss in the discrete time domain, but we will discuss in discrete through the sampling. So sampling and discrete time signals and system. So after sampling, you will enter in the discrete time signal, where we will discuss about x of n. Again, we will discuss here about the operations on signal, the basic classification of signals, energy, power, even, odd, periodic, non-periodic, conjugate, symmetric, है ना, anti-symmetric. After that, causal, non-causal. Again, we will discuss about the properties, variant, invariant, linear, non-linear, convolutions. Everything we will discuss in chapter number 4. Chapter number 1 and chapter number 4 has a symmetricity, my dear student, because this is dedicated for CT, this is dedicated for DT. Chapter number 5 will be discrete time Fourier, discrete time Fourier analysis, discrete time Fourier analysis, and here we are going to discuss about, first of all, DTFS, that is discrete time Fourier series, then discrete time Fourier transform, DTFT is very important. After that, we'll also discuss about the DFT, discrete Fourier transform, and last we'll discuss about the first fast Fourier transform. So if I talk about double E student, for double E students, DTFS and DTFT is only important. DFT and FFT is specifically important for electronics and instrumentation student, because for double E student, generally questions not coming from DFT and FFT, and it is not even mentioned in the syllabus also. So in the GATE syllabus of double E students, DTFS and DTFT till now you guys can study, okay. And the last chapter, that is chapter number 6, will be Z transform, So again, my dear student, if I talk about the DTFT, it is only applicable for the bounded types of signal, just like the CTFT. But if we talk about the Laplace transform is applicable for the continuous time unbounded signals. Similarly, this Z transform is also applicable for the discrete time bounded and unbounded signals. It means, yes, I am starting with a intention that I am going to teach in a conventional way. In a conventional way, we are going to discuss each and every topic. Okay, so right now we are starting the chapter number 1, and we'll discuss the complete chapter number 1, and after that I will check your all commitment. Okay, sir, आप उनके दिल में हमेशा रहेंगे, जिन स्टूडेंट्स का सिग्नल एंड सिस्टम प्राइवेट सब्जेक्ट होगा, अगर नहीं भी हो तो ला दे. चलिए, थैंक यू सो मच बेटा पुरुषोत्तम, थैंक यू सो मच. आई एम वेरी हैप्पी to again seeing you all Loyan army is here. Chali. So here is Z transform, guys. Here is we have Z transform, discrete time Fourier transform, sampling and all. So we have chapter number 1 to 6. The Laplace transform is quite similar to the Z transform. Why? Because this is applicable for CT, this is applicable for the ZT. What is the difference, sir? Here is integration, here is summation, here is S plane, here is Z plane. Here is, we can say that for the stability, ROC must include imaginary axis. Here the imaginary axis will map into unity circle. Left hand side will map into inside the unity circle, and right hand side of S plane will map into outside the unity circle. So these are the symmetricity between the syllabus also, guys. Chapter number 4, 5, 6 is dedicated for the discrete time domain. So as far as GATE syllabus is concerned for signals and system, it is totally defined on the basis of time axis. If I talk about the signal can be classified in two parameters. One is amplitude, one is time domain. So as far as GATE syllabus is concerned, in the GATE syllabus, we are talking about the classification of signals on the basis of time. It means first is continuous time, second one is discrete time. That's all. Yes or no, guys? Chali. So now I am going for the next slide. If I talk about the next slide now, the first thing come in your mind is, sir, what are the signals and system? So as I already told you, today's class is the basic introduction part. We can say that theoretical part we are going to discuss here. I just want to create the environment of signals and system. From the next class, we will have a transformation operations on signals. We will have many numerical problems also. From the next class will start. On today's class will be dedicated for the introductory part, theoretical part. I am just trying to create the environment of signals and system, guys. So if the signals and system word is coming in the mind, if I talk about first of all signal, so you must say that signal is anything which gives some information about the nature and behavior of some phenomena. Signal is a physical quantity that vary with, you can say that signal is a physical quantity, signal is a physical quantity, signal is a physical quantity that will vary that will vary with time, space or any other independent variable. Time, space or any other independent variable or any other independent variable, any other independent variable, any other independent variable. Independent variable. It means for any signal, we are having two types of variable. One is dependent and one is independent. If I talk about the signal, then the signal is a single valued function. Single valued function. It means if we have any signals, if we have any functions which is like this, at one time, let us assume that it is time axis. So at time t equal to 1, if the signal is a x of t, then this is also representing x1 and this is also representing x1 value. But it is not true for the signals. So it is not a signal. It is not a signal. So to make a signal, signal should have carry some information. Very nice, which carry one meaningful information. It means, my dear student, signal is a single valued. Yes or no? So what you can say that signal is a physical quantity that vary with time, space and any other independent variable, and also carry some information. Yes. So I think Gautam already made the classroom notes from the last my classes only. That is why. Yes or no? चलिए, many students already completed some chapters. So what is expectation from your side? You should share your experience to your juniors and convey this information that now you guys, all guys, they can follow Ankur sir on the IMS Gate Academy platform, or those who are looking for the comprehensive preparation for the GATE 24-25, they can definitely visit our IMS Gate Academy Center in Bangalore, Jayanagar. Those are in the nearby area. And otherwise, you guys can have a call and you have a discussion with our student advisory team. They will guide you about the online batches also. Okay, guys. So now, if I talk about signal, anything which gives some information, about the nature and behavior of, some phenomena, the behavior of some phenomena, about the nature and behavior of some phenomena. Yeah. So student, these are the pointers you can write for the signal. So if I talk about the examples, if we talk about the electrical network, then in any electrical network, the voltage and current equation will be working as a signal, and your electrical network RLC component, your device, your physical components will be working as a system. So if I talk about the signals and system, again different examples. So now this is all about the signal that you can write. If signal is depending on one independent, if I talk about, I think this part is completed. Shall we go for next slide? Guys? Yes. So if I talk about, sir, x of t, then here this t is actually representing, my dear student, independent variable, and this x is representing, my dear student, dependent variable. So if signal is depending only on one independent variable, then it will be known as one-dimensional signal. So the signal, I can say that one-dimensional signal. If I talk about the signal x is T1, T2, then you can say that it is a two-dimensional signal. Because if signal depending on one or more independent variable, it will be referred as a multi-dimensional signals also. So if I talk about the image signals fxy, the image signal will be representing as a two-dimensional signal, where you can say that, sir, in the image we are having these types of axes, x-axis and y-axis. So two independent variables are required for the image signal. Similarly, if I talk about the video signal, then x and y will remain same, and one more one more independent variable will come, that is time domain. So if I talk about for a video signal, the independent variable will be x, y and t. So these are the, for this is the signal that is known as video signal. So for the video signal, the independent variable are x, y and time. So for the time domain, whatever the movement of the image is, that will reflect as a video. That will reflect as a video. So my dear student, there is a fluctuation of image on the time, but the time is very small. So that is why the movement of images, actually we are thinking that it is running with a time. So it is looking as a video, but it is nothing but a combination of images, faster movement of images. Yes. Now if I talk about the next part, student, system. If I talk about the next part, that is system. So system is a meaningful interconnection of physical devices. System is nothing but a meaningful interconnection of meaningful interconnection of physical devices or component. Meaningful interconnection of physical devices or component. So it means system is definitely made for some purpose. System gives us an organized output. System gives you a proper output. So student, we can say that if it is a system, it will definitely receive an input signal, and the system will process the input signal and provide us the another signal, that is known as the output signal. So signal is a meaningful interconnection of physical devices or component that will provide a proper output. In the control system class, I told many times, so control system subject hoga. Yes, control system subject also will try to start, guys, but one by one. First we are starting signals, and after that, once I will get time, we'll planning for the control also very soon. Because you are talking about control, here also one word, that is system. So can you relate, my dear student, in a fan, if there is no airflow, it will not even work as a system. In a fan, in example of a fan, if I will remove all the blade, then there will be no airflow. It means it will not at all work as a system. Because if something which is working as a system, the output should be in a organized way. The output should be in a proper way. So what we can say that, guys, system is nothing but a meaningful arrangement of, meaningful interconnection of physical devices. It means in a fan, if I want a proper output, then it means there should be a proper airflow, and to generate a proper airflow, I need to connect all the blades in a meaningful order. I need to connect. I can't connect all the blades very near to each other. I should make a proper space. I should make a common, or we can say that maintain a common space in between all the blades. पैरेलल में कंट्रोल सिस्टम करा दीजिएगा सर. बिल्कुल बेटा, definitely I am also continuously busy in the others responsibility also. Still I am finding some time, and we are having the live YouTube sessions. Also I will try my level best to start with control, but right now I am not giving you any date, just like signals, because many students writing. So that is why we are starting now. So if I talk about but control, definitely in my mind, maybe in between the month of May or June we can start. So now this is all about, my dear student, system. Now if I talk about the control system, as I already told you, in the control system, as far as control system is concerned, your input signal is nothing but your desired output. Because if you want to control your AC, if you want to set the temperature 22, then from the remote control you need to give the input 22. So actually you want 22 temperature from the AC, and you are providing as an input also 22. So as far as control system is concerned, the theory is different, where your input signal is nothing but the desired output. Whatever you want from the system, you need to give as an input, as far as control theory is concerned. And if the system is working in an ideal condition, then your actual output must follow the input command. And if your system is not able to follow the input command, if your system is not able to follow the input command, it means there is a fault in the system can be unstable. Because for the stable system, because if the system is stable, then definitely your output somewhere reach to your actual input. It will follow your actual input. Yes or no, guys? Similarly, if I talk about the signal, as I already told you, in the motor, in the rectifier, in the rectifier motor, electrical motor, or all the electrical network, all are the examples of signals and system. If I talk about a communication system, in a communication system, one end, the input end, will be representing as a transmitting end, and the output end will be representing as a receiving end. So if I talk about, if the information is in kilohertz, that is 10 to the power 3 hertz, that is 10 to the power 3 hertz, or we can say that, sir, if the information in kilohertz, that is 10 to the power 3 hertz, the copper cable will be working as a communication system that will use to carry the information from transmitting end to receiving end. But if the information in megahertz, then 10 to the power 6, you know that. So here the coaxial cable will be working as an system or working as a channel which is used to carry information from the transmitting end to receiving end. If we talk about the information in gigahertz, that is 10 to the power 9 hertz, we have a waveguide that will be working as a system, that will be working as a communication system or a channel which will carry information from transmitting end to receiving end. If I talk about the terahertz, that is 10 to the power 12 hertz, then we have a optical fiber that is recently added in the instrumentation branch also in the GATE syllabus. Optical fiber, generally students studied this optical fiber in the physics, in even in the 11th 12th also, or in the first year also. In the first year also we have a optical fiber. It will a total internal reflection, TIR, it will based on the principle of total internal reflection. So optical fiber will be working as a channel medium which will carry information from the transmitting end to receiving end. So as far as signals and systems are concerned, we can relate with the examples of electrical network, motor, electronics device, electrical network, or we can say that rectifier, or we can say communication system, control systems, like that. So this is all about the introductory class, as I already told you. Now guys, if I talk about the signals classification, so we can classify the signals on the basis of two criteria. The first is amplitude, and the second is time. So if I talk about the amplitude axis can be in the continuous time, in a continuous way, or in a discrete way. So if the amplitude axis will be in a continuous in nature, or it can be discrete in nature, So if it is in continuous in nature, that will represent actually analog, term. And if it is in discrete, then actually it is representing the signal as a digital. Because the amplitude axis will reflect. If the amplitude axis is continuous, we can relate with the analog signal. If the amplitude axis is discrete, then it will be referred as a digital. But if I talk about the time axis again discretized in two time, defined in two time, or classified in two time. That is continuous time, and that is the discrete time. So this is what, guys, continuous time and discrete time, and this is all about our syllabus. This is all about these types of two signals that only we are study. We have studied the continuous time signals. After that, the application of continuous time signal, classification of continuous time signal, operation on continuous time signal. I am also going to teach how to write the mathematical equation and how to integrate and how to differentiate the signal waveform in a short trick. That also I am going to teach in the upcoming weekend, okay, in the upcoming classes, okay. So you will see the upcoming classes thumbnail also in the advance, guys, okay. So you can make a reminder also. You just click on that. So whenever we will be live, you will get the instant notification. Those who have not subscribed the channel yet, you guys need to subscribe this YouTube channel also and hit the bell icon also. Okay, guys. So whenever I will be live, you will get that. And I'm just telling you all, guys. Parallelly, other subjects, if your friends are from mechanical, civil, computer science, so engineering maths is also running every Thursday and Friday. Similarly, other subjects also, other branch subjects also are running. Okay, guys. So here is continuous time, discrete time. So this is what continuous and discrete. This is referred as analog, digital. So now one by one I will take the different basics of signals. So if I talk about the first basic signal, that will be representing as a CACT signal, which is referred as continuous in amplitude, which is referred as continuous in amplitude, continuous in amplitude, and continuous in time. It means signal is amplitude axis is y-axis. You know that amplitude axis is nothing but representing as a y-axis. Similarly, if I talk about the time, it will be signal represent in the form of x-axis. Okay. So if I talk about the continuous in amplitude, it means y-axis also continuous and time axis also continuous. So it means the signal will be in a continuous nature and signal is defined for all values of time. And in the magnitude also, if I talk about the signal ft, then it can be my continuous time signal, which is defined for each and every value of time. If I talk about the other example, we can say that, sir, exponential signal is also continuous in amplitude and continuous in time signal, like that. You must say that, sir, it is nothing but e to the power at exponentially growing signal with respect to time. If I will relate this signal as a f of t, then t is my independent variable and f is my dependent variable. Similarly, if I talk about exponentially decaying, then it is nothing but e to the power minus at. However, both are the unbounded signals. What is the definition of unbounded? If any signal goes to infinity at any value of time, will be referred as a unbounded signal. If I talk about the sinusoidal signal, then sinusoidal signal will also representing as a CACT signal. CACT refers for continuous in amplitude and continuous in time. So this is nothing but my f of t with respect to time, and all are the four examples of a CACT signal, continuous in amplitude and continuous in time signals, continuous in amplitude and continuous in time signal. Why, sir, it is continuous? Because if it is a time axis, guy, if it is a 0, if it is a 1, if it is a 2, if it is a 3, if it is a 4, if it here is 3.5, then the signal is defined for each and every value of time. It means here, if I will take a point, then this signal will give me the value of f1, this signal will give me the value of f2, this signal, this value will give me the value of f3.5. So it means in the time axis, at any point, any integer point or fraction point, at each and every time axis, the signal is defined. Those particular types of signal will be referred as a CACT signal, continuous in amplitude and continuous in time signals. I hope this signal is clear to you. So just do reply, guys. Shall we go for next slide? All of you guys just do reply. Shall we go for next slide? Thank you, sir. वापस signal चालू करने के लिए. Yes. Very good, beta. Because many students are writing, so that is why I am starting. I have only one motivation to teach you guys. You should be attend all the classes in a regular way. That is why I have made the timing in morning. So from tomorrow we'll have the timing 11 a.m. to 12. Daily morning we'll meet for 1 hour, and in 1 hour we will discuss. Okay, guys? And classes generally on the weekdays only, not on weekend. Okay. Waiting for this. Finally, I have the studies earlier and was missing it. Rishabh, thank you so much, beta. Rishabh, हवा में उड़ा दे. क्या बात है यार. चलो, वेरी गुड, वेरी गुड. हमारे डायलॉग आपको याद है अभी तक? यस. जो भी स्टूडेंट पहले पढ़े हैं, ज़रूर आप अपने जूनियर्स को ज़रूर बताएं, अपने क्लासमेट्स को ज़रूर अपना एक्सपीरियंस शेयर करें, बताएं उनको कि कौन है अंकुर सर, कैसा पढ़ाया अंकुर सर ने, और क्या अंकुर सर का पढ़ाया आपको कुछ काम आया, आपको कॉन्फिडेंस दिया सब्जेक्ट में. अगर यस, तो डेफिनेटली you can say, this is a way to say thanks. If you will share your information to everybody, okay? Wherever you will get a scope to share your experience, definitely don't hesitate, just share it with full of energy. Yes or no guys? कोई नहीं है टक्कर में, काहे पड़े हो चक्कर में, कोई नहीं है टक्कर में. शाबाश, very good. So now if I talk about continuous in amplitude and continuous in time, this is all about the examples of a continuous in amplitude, continuous in time signal. If I talk about the second types of signal, that is continuous in amplitude but discrete in time, that is actually referred as a discrete time signal. So it is actually continuous in, amplitude but discrete in time, but discrete in time. Yeah. It means what, my dear student? To perform to generate a CADT signal from a CACT signal, we have to perform sampling. So let me take an example. If I am having a CACT signal, if I am having this signal as a f of t with respect to time, I am just telling you guys, just share the link of the video to all your juniors, those right now in second year or third year or even first year. I am telling you, in the upcoming days, you will feel proud when you will see your class, your notes, okay, your notes, because every topic, whether we talk about any topic which I will pick in the coming days, you will feel full of confidence and will teach in a most unique way. Okay guys, हम नेक्स्ट क्लास के अंदर जो क्वेश्चंस पढ़ेंगे वहाँ से प्रॉब्लम स्टार्ट हो जाएंगे, वहाँ से क्वेश्चन स्टार्ट हो जाएंगे और आप हर एक चीज़ को एंजॉय करोगे कि सर ये इतना आसान था क्या. I will make it easy for you, but the requirement from your side is, guys, your energy, your regularity. So this is my FT, this is my effort. Let me take, this is my CACT signal. So this is nothing but my CACT signal. If I want to generate a CADT signal from that, it means I need to perform one operation, and that is known as sampling operation. And do you know, in the sampling actually what we are doing? We are just replacing T with NTS. So here I will get a discrete time signal Fn with respect to n is nothing but the integer only. It means what, guys? Actually what we are doing here, we are just taking a different samples after the TS interval of time. After TS interval of time, this is FT, and here I will get Fn. It means that every after TS, this switch will be closed and I will get the sample. Just like that. Just like here, if let me take this time period is TS. So the second 2 TS, the third is 3 TS, like that, the 4 TS, like that. It means after this particular duration of time, we are picking the signal values. Okay, so first signal value is this, second this, third this, like that. If I will note as a ABCD, then A, B, C, D, E, then these values I will get here. So I will get the 0 value is nothing but A. The 0 value is nothing but A. If I talk about the TS time, at the TS instant of time, what is the value carried by the signal? That is B only. So it is nothing but the B, like that, B. If I talk about the next, then it will be nothing but C. So C will be like this at the time of 2 TS. After that again D, like that. So this is C, this is D, this is 3 TS, and after that again it will be improving. So it will be E, it will be time 4 TS, and so on. So like that, my dear student, we can generate a DACT signal, we can generate a CADT signal, continuous in amplitude, discrete in time. We generate a CADT signal from a CACT signal. Yeah. And you can say that in a CACT signal, your amplitude axis is still in continuous in nature, and your time axis is actually in discretized nature. And because time axis is in discretized nature, it means the signal is not defined for all values of time. It is only and only defined for a particular instant of time. And that particular instant will define by the by that this time duration ts, and after that it is just depending on the integer number, where n is a integer number. So let me, if you are taking ts as a 2, then here is the difference 0, 2, 4, 6. If your ts is 4, then 0, 4, 8, 12, like that, because n is nothing but the integer. It means in the discrete time signal, if I am representing this notation, then I can't represent my signal at one location, at 1.5 location. It is only defined for 0, 2, 4, 6, because I already fixed this ts, that is nothing but the sampling time, and sampling time is reciprocal to the sampling frequency as well, 1 upon fs as well. I hope it is clear to you guys. I hope it is clear to you. So this is just nothing but the simple sampling, how we can generate the continuous time CA-CT signal, CA-DT signal from a CA-CT signal. Let me take one more example. If I am taking the example of a sinusoidal signal, let me take if ft is nothing but the sine of omega 0 t. So if I am having a sinusoidal signal just like this, if this is my sinusoidal signal, then you can say that, sir, it is nothing but a CA-CT signal. If I want to perform a sampling here, then what I need to do, guys? I need to replace this t with NTS, so that I will get the next signal f of n. I will get the next discretized signal in time, that is nothing but fn, and it is actually nothing but CA dt. So this is the conversion of, this is the mapping from CA-CT to CA-DT, and here in this equation, if I will replace t with NTS, then my equation will be look like this, guys. Sine of what I am doing, I am just replacing t with NTS. So here is sine of omega 0, and this t will be replaced with as a NTS. So now my new discrete time signal will be look like as omega 0. What about TS, guys? TS is nothing but Fs, sir. So here you can say that Fs and into n. So now this complete part is nothing but the discrete frequency. So this is nothing but the omega d, that is frequency for the discrete time signal, and it is nothing but equal to omega 0 into 1 upon Fs. So if I talk about omega d, this is the frequency of discrete time domain. Omega 0, this is the frequency for the discrete time signal. Omega 0, this is the frequency of a continuous time signal. And Fs is nothing but the frequency of a, or we can say that sampling frequency. Sampling frequency. However, sampling part, here if you will open it like this, 2 pi fd is equal to 2 pi f0 upon Fs. So here 2 pi get cancel out. So ultimate relation between the discrete time frequency fd is nothing but f0 upon Fs. This is the important formula which is even helpful for the discrete time calculations also, guys. Yes, very good. So f0 Fs, f0 is the frequency for the continuous time domain, Fs is a sampling frequency, and fd is a discrete time frequency. So this is just the process of sampling, and here after Ts interval, if I am taking a different interval, then I will get a discrete time signal just like that. Sinusoidal signal just like this. This is my sinusoidal signal. Like this you will get. So this is nothing but the continuous in amplitude but discretized in time. Just like this. So this is your f of n. This is your discrete time signal. This is your continuous time signal. Continuous time. From continuous time to discrete time, this is how we can convert. From continuous time to discrete time, this is how we can convert. Yes or no? Chali. All of you guys just do reply fast. Is this part completed, guys? Chali. I think this part is completed. This part is completed now. Yes. So if I talk about the next signal, that is nothing but discrete in amplitude and continuous in time. Yeah. It means if I talk about the sampler, sampling procedure, sampler. So sampler is used to convert a continuous time signal. It is used to convert a continuous time signal to a discrete time signal. It is used to convert a continuous time to discrete time. So sampling is a process that is used to convert a continuous time to discrete time signal, whereas the quantizer is a procedure, that is used to convert a continuous amplitude signal, to a discrete amplitude, to a discretized amplitude. So if you want to make changes in the amplitude from the continuous to discrete, sir, waiting for the more class. Electrical, yes. So this is the first introductory orientation class of signals. This is the first introductory class, my dear student. In the upcoming class, we'll have many questions, operations of signal, mathematical representation, how to write the equation, how to make the curve from the equation, how to integrate in signal waveform, how to differentiate, how to find convolution, how to apply the properties of impulse, rectangular signal, everything we are going to discuss, sir. Sir, your signals classes helped me a lot in my GATE preparation. Thank you so much, Electrical, for your lovely words, for sharing your experience. I just want that each and every student just share your true feeling with all your juniors. जो भी आपका सच्चा एक्सपीरियंस रहा है वो अपने जूनियर्स को दहाड़ के बताओ यार, जरूर जाके बताओ कि कैसा आपको लगा पढ़ने के बाद और क्या आपका एक्सपीरियंस रहा और कैसे आपको उसका फायदा मिला. यस, चलिए. So it means quantization, guys. If I talk about the quantizer, so let me take the example. If we have a signal just like this, CACT signals. So if we have a signal just like this, so this is sinusoidal signal. If I want to perform a quantizer here, then how it will work? You just see that. We just want to. So this is my CACT signal. And this time I want to convert in DACT signal. It means time domain remain in continuous nature. Here is also continuous and here is also continuous in nature. Now what I want to do, student, here if I will make a different levels. Here I will make a different levels. Okay, just like that. Suppose that if we have a mid value, of the signal is 4 and here also -4, like that. I am just taking a signal values. Okay, yes. So let me take this value as a 0. Let me take this value as a 4. Let me take this value as a 8. Let me take this value as a -4. This value as a -8, like that. So in the quantizer procedure says that we have to just make a average in the amplitude. It means if I am making a levels here again, so what I want to do, because my levels are like this, yeah. So first level is nothing but 4. Yes or no, guys? 4. So here if I am starting with second level is 8, that you know, yes or no? So here let me take some space. Yes. So if this value is 4, this value is -4. Okay, this value is -4. Now we have to create a levels. Yes. If I am making a signal line here also, if I am making signal lines here in between 0, yeah. Then how we can approximate? Sir, if this is the 4 value, this is the 8 value, this is the -4 value, this is the -8 value, then we can make a level here between 0 to 4, or level is 2, and between 4 to 8, or level is 6. It means if the signal from this point to this point, whatever the signal, it will be approximated to the 6 value only, because it will take only finite levels. It will only take the finite levels. Yes. So whatever the signals going between 0 to 4, it will be equivalent to 2 level, and whatever the signal values between 4 to 8, now it will be now it will be approximated to the 6th level only. So now I am creating only 2 level, one is 0, 2 and 6, and similarly in the lower side -2 and -6. Now going forward, my signal value will only have these 4 levels. It means the signal can't take 3, signal can't take the magnitude 8, 9, 100. It will only take 0, 2, 6, -2, -6. So these are the only levels. Now I am converted my continuous time signal to the discrete continuous amplitude signal to the discrete amplitude signal, because either the signal is having 2 value or 6 value or 0, -2, -6, that's all. So if I want to make a complete diagram here point to point, then the diagram will be look like this. At this point, like that you can connect. So directly student, directly from this whatever we are studied today, directly this is important for the interview point, viva point, not so much important directly for the gate problem. From the next class the problems will start. The next class the gate questions also going to be start, guys. Okay, so between 0 to 4, as I already told you, we have a levels. So now 2, 6 level. So between 2 to this, between this to this point, we are having the signal value 2. After that between this to this, we are having the signal value 6. Again we are having 2, and after that again from here we are having 2. For this we are having 6. For this we are having 2. Like that we are traveling, guys. Like that I hope you are getting. Like that I hope you are getting. Like that. Yeah. So now we are this signal is converted into only discretized in amplitude and continuous in time. Yeah, time axis is continuous and the discrete, this axis is nothing but the discrete axis. This axis is nothing but the discrete axis. Still it is in continuous time domain. So independent variable is time, but the amplitude axis is now quantized. The amplitude axis is now quantized. Yes or no? Yeah. So this is our DACT signals. Now the fourth signal, if I want to generate, that is nothing but, guys, the DADT signal. It means the name suggests so discrete in time or discrete in amplitude. So it will be discrete in amplitude and discrete in time. Discrete in amplitude and discrete in time. It will be discrete in amplitude and discrete in time. Yeah. Discrete in amplitude and discrete in time. It means what, guys? Here two procedures we need to apply. We need to apply sampling also. We need to apply sampling also, or we need to apply quantization also. We need to apply quantization also. So if I will apply both, my dear student, the DACT signals will be look like this, where this axis will also be in the discrete time, or where the amplitude axis will also be in a discretized in amplitude. The signals will have a levels only. So let me take the levels is 1 or 3 only. If the signals is having the level 1, 3 or -1, -3, and the time axis is also, if the TS, if the TS is I am taking 2, if the sampling time I am taking 2, then only we are having signal with 2 to interval 0 to 4, 0 to 4, 6, 8. It means in between 2 to 4 signal is not defined, and it can take only the different level value only, that is 2 value, that is 1. It can take 1, it can't take 2, it can take only either 1 or 3 or -1, -3. So it can be 1, it can be 3, it can be -1, it can be -3, like that. Again I am taking down now 10, it can be 1, it can be 3. So like that my signal will vary. Why I am talking about discrete in amplitude? Here other than 1 and 3 no value is possible. 1.1 is not possible. 1.5 is not possible. 3.9 is not possible. Even 5 is also not possible. 10 is also not possible, because now it is discretized in amplitude. So even what is the difference between CACT signal and DACT signal? In the discrete in amplitude, in the amplitude axis also we are predefined. It means we can't make any values. We will have only a fixed values, fixed level values. Is it clear or not? So now we are having predefined values in amplitude axis also, or in time axis also we are predefined. It means the signal can't represent at 9 value, signal can't represent at 9.5, amplitude can't take value 1.5, amplitude can't take value 2.5. Is it clear? So this is all about the basic difference between the four. I hope it is clear to you guys. I hope it is clear to you. So the four signals we have discussed, that is CA-CT signals, that is CA-DT signals, that is DA-CT signals, or discrete in amplitude, continuous in time, and last is DA-DT signals. Now, as far as amplitude access is concerned, guys, as I already told you, CA, because amplitude is in continuous manner, so will be represented as a analog types of signal. If I talk about the amplitude in discrete domain, because the amplitude in discrete will be referred as a digital kind of signal. But the signal will be referred as in time domain, continuous time, discrete time, continuous time, discrete time. Is it clear, guys? So these are the four classification of signals we have discussed. Hello, Mohammed. Good morning, good morning, good morning. Chali. So now if I talk about the next part, guys, these all are the reference books, okay? So as far as GATE is concerned, or classroom notes is more than sufficient. Those who are attended all the comprehensive batch, okay? If you wish to join, if you want to do your entire GATE preparation under my guidance, then you can definitely join the IMS GATE Academy also. IMS GATE Academy provide you the structure course. Those who are your junior and about to start this GATE preparation, then you can definitely refer, and they can just watch the sessions also, signals and systems, so that they will get to know how they will get benefited if they will just part of the IMS GATE Academy, and if they will join the IMS GATE Academy for their GATE preparation. So here I have just mentioned some good signals and system book for the practice of questions. Okay. Good morning, Mohammed. Good morning. Yes. So guys, this is all about, we can say that signals, that part we have completed already. System part, DA-CT signals part. Transformation of signals. That is what? Transformation of signals I am going to start in the next class. Okay. Transformation of signals we are going to start in next class. So every day we are having one hour class. Okay. Every day we are having 1 hour class. From tomorrow we will start the class at 11 a.m. 11 a.m. to 12. 11 a.m. to 12 p.m. And tomorrow class will start we will start the operations on signal, transformations of signals like time shifting, time scaling, amplitude reversal, everything we are going to discuss. Everything we are going to discuss. Okay, guys. So how many of you will be regular in the classes? Tell me, guys. Because if you want that you will get all the lecture in a sequence form, then there is only one requirement from your side. There is only one expectation from my side, that you all should share your past experience or present experience to all your classmates, to all your juniors. Digital bhi karwa denge. Digital already running right now on our YouTube channel. Digital is already running right now, and once I will get time, I will also start. Okay. For control question series also going to start. Some students are requesting कि सर थोड़ा question series भी करवा दीजिए. So definitely I am planning. Okay, guys, I will plan each and everything for you all. Not only for EC electrical. If someone is from mechanical or civil and those are your friend, you can also suggest them to just subscribe IMS GATE Academy. Just follow IMS GATE Academy platform. There you will get on the IMS GATE Academy YouTube channel, they will get the session for SOM subject also, TOC subject also, and COA, operating system, for each and every branch. So I am planning for every branch here, my dear student. You just need to share your experience. Because last year in GATE exam, it helped me a lot, sir. Complete होने से ज़्यादा time लगेगा. Complete होने में ज़्यादा time लगेगा. Correct. Purushottam. Yes, Purushottam. So we can increase the time limit also. It can be 1 hour initially. In later on, it can be 1.5 hour also. Okay. But I'm just observing your dedication level also. Okay, guys. Yes. So application, if I talk about the Laplace, as I already told you in the drawback of Fourier transform, it's only applicable for the bounded types of signal. We can't find the Fourier transform of e to the power at ut. We can't find out the Fourier transform of e to the power at ut. E to the power at ut Fourier transform is not possible. Why not possible? Because this signal is an unbounded signal. Because if I talk about e to the power at ut like this, the signal is going to infinity at infinity value of time. It means the signal is an unbounded signal. And for the unbounded signal, the signal is not absolutely, those signal which is not absolutely integrable, the Fourier transform is not defined. But for this, Laplace transform is defined. E to the power at ut, the Laplace transform is nothing but, 1 upon s minus a. And what is the range of sigma here? Sigma is greater than a. So this range of sigma is representing this, for this particular range of sigma, that is nothing but the region of convergence. Digital भी आप देख लीजिए ना sir. बिल्कुल पुरुषोत्तम, we'll try for digital also, but as of now, right now, you can enjoy signal, and in the upcoming days, definitely I will try to take other subjects also. Okay, guys, but one sincere effort from your side. Okay, guys, just share your true experience. Okay, चलिए, so जरा हमारे उसी पॉपुलर डायलॉग के साथ क्लास को ऐड करेंगे बच्चों। काहे पड़े हो चक्कर में, कोई नहीं है टक्कर में, पूरे इंडिया में जाके बताओ यार कौन है अंकुर सर, कैसा पढ़ाया अंकुर सर ने आपको, और क्या क्या आपको बेनिफिट हुआ अंकुर सर की क्लासेस से। अगर एक्चुअली हुआ है, अगर बहुत से लोग जो रैंक लेके आए हैं, अगर उन तक भी ये वीडियो पहुंचे, तो अपने एक्सपीरियंस को कमेंट में जरूर लिखिएगा यार, नॉट इन चैट बॉक्स, बिकॉज मे बी चैट जो है फ्यूचर में स्टूडेंट्स देखे ना देखे, लेकिन कमेंट जरूर फ्यूचर लर्नर्स जरूर पढ़ेंगे। तो अगर जो भी आपका एक्सपीरियंस रहा है, अगर आप कहीं भी जो मेरे स्टूडेंट्स हैं जो टॉपर्स रहे हैं, जिन्होंने गेट को अच्छे क्रैक किया है, 1 डिजिट डबल डिजिट रैंक मिला है जिनको लास्ट 12 ईयर में, अगर आप तक ये वीडियो पहुँचे तो ज़रूर थोड़ा टाइम निकाल के अपने एक्सपीरियंस को कमेंट में लिखिएगा, और अपने एक्सपीरियंस को शेयर करने में कंजूसी मत करिएगा। पूरा जो एक्चुअल एक्सपीरियंस रहा है आपका, वो 100 वर्ड्स में पूरा लिखो, पूरा अच्छे से लिखो, ताकि फ्यूचर में जो भी इस वीडियो तक आए उसको पता चले कि उसको क्यों ये प्लेलिस्ट को फॉलो करना चाहिए, क्या अपकमिंग लेक्चर्स में होने वाला है, और कैसे वो उनको बेनिफिट हो सकता है। ओके माय डियर स्टूडेंट्स, यस, चलिए गाइस, सो दैट्स ऑल फ्रॉम टुडेज क्लास। Today's class I have planned for 1 hour initially every class is for 1 hour only for the next 10 days. After that, if we feel, then we can improve the length of the class. We can improve, we can make it 1.5 hour also, 2 hour also. It's just depending on your dedication level. Okay, so right now just tell me, my voice is clear or like voice is slow, or voice is not up to the mark? Am I audible perfectly, or like what? Voice is loud and clear, or it is not so loud? Voice is clear, audio, video, everything is clear, guys. Just do reply, Purushottam. Clear, sir, clear. Okay. Chaliye beta. So that's all from today's session. Thank you so much. Just follow IMS Get Academy channel, and here also in the given strip, in the running strip, you can see the numbers also. Those who are looking for the complete comprehensive GATE course, if you wish to purchase the GATE course, then definitely you must call to the given number. You will get the best guidance that I can ensure you. Okay, if you are joining IMS GATE Academy, it means you are joining Ankur sir classes. It means your GATE preparation is with Ankur sir guidance. Okay guys, chali, bye bye, thank you so much. We'll meet tomorrow. Morning 11 a.m. guys. Tomorrow morning 11 a.m. Okay, today is 2nd May. We'll meet at 3rd May 11 a.m. Chaliye, bye bye.